For this example, we're going to compute the total surface area of a right circular cone given the radius and the height of the cone. I took this screenshot from my math lab just showing the formula that we need to use, what those different parts of the formula represent, and as well a picture of this right circular cone. So some of the things that we are given is the radius. So this distance here, we could say that is the radius, 7. We're also given the height. That's this distance here. We'll call that 24 because we're given that. But we need the slant height. So we need S, slant height. Now on this particular figure, it's over here on the side, on the left side, but it's the same slant height as this side on the right side of the figure. This is the unknown dimension that we're trying to find. So we do have, again, height and radius. We don't have this third part. What we do know, however, is that this is a right circular cone, meaning that the base and the height meet at this right angle. And what that does is it creates this right triangle embedded within the cone. So what I want to do next is take out this right triangle. Just a quick little drawing here. And what I'm trying to find is this unknown side S of a right triangle. What we've learned is that Pythagorean theorem will enable us to solve for one missing side of a right triangle. So that Pythagorean theorem will look something like this. 24 squared plus 7 squared equals S squared. So what we get by computing what we see here on the left side of this equation is 625 equals S squared. After taking the square root of both sides, we get that 25 equals S. Remember S here being the slant height. So at this point, to find total surface area A, we know that we need R, which we were given in the problem. We need slant height, which we just solved for. That's going to be 25. We found slant height using the height, the perpendicular height of this cone, but notice I'm not now using that 24 within this area formula. So now the area, surface area of this right circular cone is pi times the radius 7 times the slant height 25 plus pi times the radius 7 squared. So let's put this information into our calculator. Oops. I see that it's given me the answer in terms of pi. So what I could do at this point is use an approximation for pi. The more precise of an approximation that I have here, the better final answer I will get. Rounding that to the nearest tenth is how we arrive at 703.7 square feet.